Welcome to the deep dive. You ready to jump into something kind of wild?
I'm ready.
Okay, we're diving into the world of material science and advanced manufacturing.
Yeah, it's pretty cool stuff. We're talking about the materials that make up everything around us, like literally everything, and then how we turn those materials into the products that we use every single day.
It's like we're peeking behind the curtain of the everyday things that we just take for granted. Like, how are these things even possible, you know?
Right. Like, have you ever thought about like how a plastic bottle is made?
I mean, yeah, kinda, but not really.
Uh,
Like, I know it's plastic, but like, how does it go from like raw material to a bottle?
That's what we're diving into. It all starts with the materials themselves. Like, think about it. We've got this whole library of materials to work with.
A library.
Yeah, like imagine a library, but instead of books, it's full of like metals, polymers, ceramics, composites, you name it.
So like each material is like a different book with its own story and its own like set of characteristics.
Exactly. And knowing those characteristics is key to figuring out which material is right for the job. Like take metals, for example.
Okay, metals. Strong, shiny, what else?
Strong, yeah, definitely. Conductive, too. Think of like the copper wires that carry electricity to our homes.
Oh, right. Makes sense. So
Right.
we use metals for all sorts of things, from like giant bridges to tiny little electronics.
Exactly. They're super versatile. Now let's move on to polymers. Polymers are like long chains of molecules. They can be flexible like the plastic wrap in your kitchen,
Okay. What?
or super tough like the nylon in, say, a backpack.
Interesting. So polymers are like the chameleons of the material world. They can be so many different things.
Yeah, exactly. Now, what about when we need materials that can handle some serious heat? That's where ceramics come in.
Ceramics, like pottery.
Kinda, yeah, but think more high tech. Ceramics are known for their heat resistance.
Okay, I'm intrigued. Give me some examples.
Well, the space shuttle, for example, it used ceramic tiles to withstand the crazy heat of reentry into the Earth's atmosphere.
Oh, wow. That makes sense. Anything else?
Yeah, we use ceramics in things like dental implants because they're biocompatible, which means they play nice with our bodies.
So we've got metals, polymers, ceramics. That covers a lot of ground, right?
Almost. We've also got composites. Composites are like the all-star team of materials.
How so?
Well, they combine the best properties of different materials, like carbon fiber, for example. It's a composite that's both super strong and lightweight, perfect for things like airplanes or even high-performance sports equipment.
So it's like we're taking the strengths of different materials and putting them together to make something even better. It's like Voltron.
Yeah, you got it. And this is where things get even more interesting.
More interesting. I'm already hooked.
Well, once we have all these amazing materials, we need ways to transform them into actual products. And that's where advanced manufacturing comes into play.
Okay, advanced manufacturing. Break it down for me.
Basically, it's all the cool ways we can take these raw materials and shape them, mold them, and assemble them into the things we use.
So it could be something as simple as like stamping a shape out of metal or something as complex as like building a 3D object layer by layer.
Yep, you got it. It's a whole spectrum of techniques. And choosing the right one depends on what you're making and how many you need to make.
Okay, so we've got our materials, we've got our manufacturing processes. It's like having all the ingredients and the tools to bake a cake, right?
Exactly. But instead of cakes, we're making, well, pretty much everything. And the really cool thing is, advanced manufacturing isn't just about using existing materials in new ways. It's also about pushing the boundaries of what materials can even do.
Like creating totally new materials.
Exactly. Like, remember we talked about nanotechnology earlier?
Yeah, the whole manipulating matter at the atomic level thing, right?
Yep. That's playing a huge role in developing new materials with, like, crazy properties we could only dream of before.
Like what kind of crazy properties are we talking about?
Well, for example, we're seeing materials that are way stronger and lighter than anything we've ever had before. Like think of carbon nanotubes, these tiny little tubes made of carbon atoms. They're incredibly strong, but also super lightweight.
Wow, so we can use those to build things that are like super strong but don't weigh a ton.
Exactly. And that's just scratching the surface. There are also materials that can change their shape or properties in response to things like temperature or light.
Wait, so like a material that can like morph into a different shape if it gets hot.
Exactly. And that opens up all sorts of possibilities for things like self-assembling furniture or medical implants that adapt to the body over time.
Okay, that's officially blowing my mind. What else is there?
Oh, there's so much more. Like, how about self-healing material?
Self-healing, like Wolverine.
Kind of. But instead of healing from bullet wounds, these materials can repair themselves from things like cracks or scratches.
Okay, how is that even possible?
Well, scientists are taking inspiration from nature, looking at things like how living organisms repair themselves. And they're using that knowledge to create materials that can, like, rebond their molecules if they get damaged.
So we're talking about like a phone screen that can fix its own cracks.
Exactly. Or like a bridge that can automatically repair small fractures, making it way safer and longer lasting.
This is all sounding very futuristic, but are these things like actually happening now, or is this all just like theoretical stuff?
A lot of it is happening right now. We're already seeing some of these advanced materials and manufacturing techniques being used in like everything from aerospace to healthcare to consumer products.
Wow, that's incredible. It's like the future is already here. But I got to ask, are there any downsides to all this? Like, are there any risks or challenges we need to be thinking about?
That's a great question. And yeah, there are definitely some things we need to be mindful of. Like as automation becomes more and more widespread, we need to make sure that workers have the skills they need to stay relevant in this new world.
Right. So it's not just about the technology itself. It's about making sure that people are prepared for these changes.
Exactly. And then there are also ethical considerations to think about. Like, as we get better and better at manipulating materials at such a tiny scale, we need to be really careful about, like, unintended consequences.
Hmm. Yeah, makes sense. So it's not just about, like, can we do this? It's also about, should we do this?
Mm.
And how do we do this responsibly?
Exactly. It's about finding that balance between pushing the boundaries of innovation while also making sure that these advancements are actually benefiting society as a whole.
That's a really important point.
Hmm.
So we've talked about the amazing possibilities and we've touched on some of the challenges, but looking ahead, like where do you see all of this going? What's the big picture for material science and advanced manufacturing?
Well, I think one of the most exciting things is how these advancements can help us tackle some of the like really big challenges facing our planet,
Like what?
like climate change, for example.
Okay, yeah, that's a big one.
Right. But advanced materials and manufacturing techniques, they can play a huge role in developing, cleaner energy
Oh, I
technologies.
see. Like more efficient solar panels, better batteries for storing renewable energy, stuff like that.
Exactly. And also more sustainable infrastructure. Like imagine buildings made from materials that are like self-healing and super energy efficient.
That would be amazing.
Right. And then there's transportation. We're already seeing lighter, more fuel-efficient cars thanks to things like carbon fiber composites.
Yeah, and electric vehicles are getting better all the time, too.
Exactly. And as battery technology keeps improving, electric vehicles are going to become even more practical and affordable for like everyone.
So it sounds like these advancements are going to touch pretty much every aspect of our lives in the future.
I think so. And it's not just about like making things better, it's also about making things possible that, we couldn't even imagine before.
Like what?
Like think about personalized medicine.
Okay, yeah, I've heard a little bit about that. What's the deal with that?
Well, imagine a world where treatments and therapies are tailored to your specific genetic makeup and your individual health needs.
So like custom medicine.
Exactly. And we're talking about things like 3D printed organs and tissues for transplantation, or even microscopic robots that can deliver drugs directly to like targeted cells in the body.
Whoa, that's some next level stuff. It's like
Huh.
science fiction is becoming reality.
It really is. But as amazing as all this sounds, it's important to remember that with any powerful technology, there are ethical considerations that we need to think about.
Yeah, that makes sense. Like, just because we can do something doesn't necessarily mean we should, right?
Exactly. We need to be really thoughtful about the potential impact of these advancements on, society as a whole.
Yeah.
Like, for instance, as automation becomes more widespread, we need to make sure that that workers are prepared for those changes.
Right, so it's not just about the technology itself. It's about making sure that people are, like, ready for the future that this technology is creating.
Exactly. And we also need to be careful about, the potential for misuse of these technologies.
Yeah, good point. So it sounds like we're entering a really exciting but also kind of complex new era.
I think that's a great way to put it. It's an era where collaboration is going to be more important than ever. We need scientists, engineers, policymakers, and the public all working together to shape a future where these advancements truly benefit everyone.
Well said. This has been an amazing deep dive into the world of material science and advanced manufacturing. It's clear that we're living in a time of incredible innovation, and it's exciting to think about what the future holds.
I agree. And I think it's important for everyone to stay curious and engaged in these conversations because ultimately the future is going to be shaped by all of us.
That's a great point. So for our listeners who are feeling inspired and want to learn more about this amazing world, where can they go to explore further?
Well, we've put together a collection of resources on our website. You can find the link in the podcast details.
Awesome. And be sure to join the conversation on our social media channels too. We love hearing from our listeners, and we're all in this together.
Absolutely. Thanks for joining us on this deep dive.
And that's a wrap. Stay curious, keep exploring, and we'll see you next time on The Deep Dive.